Let's take a look at 101. This says the region D is given in the following figure. Evaluate the double integral. So we have this fxy, which is x squared minus y squared dA, by using the easier order of integration. So when I look at a problem like this, I do realize that I want to take the interval here from -1 to 1 on the x, and I ask the question, do I have a clear upper function and lower function on the whole interval from -1 to 1? And I would have to say no, because when I think of a clear upper, this one is the upper until this piece. And honestly, it's not, it's the lower as well. So because I ran into those issues, that tells me right away that I'm probably not going to use this order of integration. So now I think of it sideways. So now I'm thinking of the y-axis now here. Now on this interval, do I have a clear upper and lower? Now remember in the last video I claimed that the function that's further right is the function that's going to be on top. So that's going to be the upper function. So this orange one here is actually going to be the upper function, and this blue one here is going to be the lower function. And you notice that it is above, or I should say further right. The orange one there is further right, and that's the y to the fourth minus y to the fourth equals 1 minus x. And that one is actually further right, so that means it's going to be the upper function because it's on the whole interval, it's further right. So that's what that tells me. So that means if we're talking about our integration, let's get what that means too here. So when I think of the further right one, now think about this here. I'm running this left to right if I'm going to fill in all of that region. So in that case, I'm dealing with a change in x. So I'm dealing with a dx. So now if I'm dealing with a dx, that means I'm dealing with a function x equals some function of y. So that's going to be where we're going to start with this. So that means we're going to start with dx, and our bounds are going to be functions of y. So that means for these two equations here, I'm going to have to get them in terms of x, I should say solve them for x's, and get the other side in terms of y's. All right, so what that means here, now if I look at this first one here, which is the blue one, that would mean for this one then that this is going to be x equals y to the fourth minus 1. And then if I look at that orange one over there, and I want to solve this one for x, this is going to be x equals, y to the fourth, I should say negative y to the fourth plus 1, or let me write this another way. This is going to be 1 minus y to the fourth. So now having both of those equations solved for x, which means I get a function of y, and that's what we see down here. So therefore, now we have our upper bounds, and the upper bound is going to be the orange function here, which is x equals 1 minus y to the fourth. And the bottom function is going to be this blue one here, and that's going to be x equals y to the fourth minus 1. So now all we're going to do now is just set up our double integral. So to do that, we're going to say, okay, here's my integral here and here. So again, that upper function is going to be 1 minus y to the fourth because that's a further right function. And the lower function is going to be y to the fourth minus 1. So then think about the other bounds for this thing. So now remember that I was talking about on the y-axis here. And you notice that they run from -1 to 1 on the y. And those are going to be the bounds for the y value. So I'm going to say -1 to 1. And then we have the function that's already given to us here in the original problem here, and that's that x squared minus y squared. And then I'm doing the dx first. Oh, I forgot my 1 here, where it disappeared on me. Okay, there it is, dx, and then I'm going to do the dy last here. Okay, so now what we're going to do is we're just going to run through this integral. So remember, we're doing dx first. So I'm going to take the integral of the x squared, but the y squared is a constant, so that's going to actually just go along for the ride. So what we end up with is the integral from -1 to 1, which we're not touching yet. And then for the first integral with respect to x, I'm going to get 1/3 x cubed. And then for the next one, I'm going to get y squared x. And that's going to run from y to the 4th minus 1 to 1 minus y to the 4th. And then dy. So now we plug in the integral from -1 to 1. We plug in the 1 minus y to the 4th cubed minus y squared, and we have our x here, which is going to be the 1 minus y to the 4th. And now we're going to subtract the lower bound. I did not give myself enough room here. Now minus the lower bound, which is the 1/3, and y to the 4th minus 1 to the 3rd minus y squared, y to the 4th minus 1, dy. All right, so now we're going to clean this up some more. That's the integral from -1 to 1. And when I multiply this through this, oops, I forgot my cubed here. Okay, so when I want to multiply that through now, we get -y to the 12th plus 3y to the 8th minus 3y to the 4th plus 1. And this is all still times that 1/3. And then for the minus part here, that's going to be minus y squared plus y to the 6th. So now we're going to expand the second piece here in this subtraction. So that'll be minus, and we still have this 1/3 here, so I'm going to leave that there. So 1/3. And this y to the 4th minus 1 cubed is going to give us y squared minus 3y to the 8th plus 3y to the 4th minus 1. And then minus, now we're going to do this piece here, y to the 6th plus y squared. And that's dy. Barely fit that in there. Tough fit. Okay, so now let's simplify this some more. So to simplify this more, now I'm going to distribute this 1/3 through to all of these terms here. So that's going to give us the integral from -1 to 1 of -1/3 y to the 12th plus y to the 8th minus y to the 4th plus 1/3. Oops. I'm trying to fit this all in. And then I'm going to get a minus y squared plus y to the 6th. And then for the rest of this, now I'm going to distribute this 1/3 through before I do the negative. I guess, yeah, I'll do it before I do the negative. And where did this stop? Oh, it stopped here. Missed a parenthesis. All right, so make sure you put that in if you missed it. Okay, so that's going to be minus 1/3 y to the 12th and then for the next one, I'm going to keep this parenthesis. I'm going to worry about that in the end. So then this is then going to be minus y 8th, and then plus y to the fourth, and then minus 1/3, and then I'm going to get minus y sixth plus y squared, and that's going to be dy. So now let's go one more now. All right, hopefully this isn't too small for you guys to see. -1 to 1, and now what we're going to do is simplify the rest of this. Well, we're going to get rid of this negative now. We're going to distribute it through. So -1/3, and I'm just going to write this out. So now distributing this negative through, that's going to be -1/3 y to the 12th plus y to the 8th minus y to the 4th plus 1/3 plus y to the 6th minus y squared dy. So now we're going to put together what we can here. So this is going to be equal. This is the integral from -1 to 1. And when I put my square the 12ths together, that's going to be 2 of them. So that's going to be 2/3. Let me fix my 3. Y to the 12th negative. And then I have my y to the 8ths. I have 2 of those. So that's going to be 2 y to the 8th. So plus 2 y to the 8th. Oops, let me fix my 8 there. I want everything to be clear here because we have so much mess here. So I got this y to the 4th, this y to the 4th, and that's it. But before we do the 4ths, we should do the 6ths. So there's a 6 and there's a 6. So that's 2y to the 6th plus. Okay, now let's do our 4ths. So I have a -y to the 4th, -y to the 4th. So that's -2y to the 4th. And then we have our numbers. So there's a 1/3, a 1/3, and that would be it. So 2/3 plus 2/3 dy. All right, so now we have all of this here. Now this simplifies to our last integral. Oops, one mistake. I forgot one more piece before the 2/3 there. I almost forgot my y squareds. I have 2 of those as well. Easy to miss something here, guys. So this is minus 2y squared, and then I'll do the plus 2/3 on the end. And that would be dy. So now this integral, we're going to integrate, and it's all power rules here. Polynomials are nice to take integrals of. So this is going to be -2, and this would be over 39 y to the 13th. And this is just thinking of that power coming down derivative idea. So if I do the derivative of this, I bring the 13 down. It's going to cancel with that 39. I get a 3 left, and now I'm back here. So we're just going to do a bunch of that now. Okay, so this is going to be the 9th. So this is going to be plus 2/9 y to the 9th. And then plus 2/7 y to the 7th. And then minus 2/5 y to the 5th. And then we're here now. And that's going to be -2/3 y to the 3rd. Let me fix my 3. 3rd there. And then we have our constant on the end, which is going to be plus 2/3 y. And that's from -1 to 1. Wow. This turned out to be quite horrible to actually do a video on. There's just so much detail here, so I hope it doesn't discourage you from doing these. So now I'm going to do upper bound minus lower bound. And what I'm going to do is I'm just going to make it appear. So there it is. And you notice there's a bunch of ones here. So for all of this first piece, that's going to be really easy to handle. So I'm going to get negative 2 over 39 plus 2/9 plus 2/7. Now I'm here. Minus 2/5. And then I'm here. Minus 2/3. Let me fix that 3. Terrible with 3's. Okay, and then I have plus 2/3. And now I have this double negation going on here because these are all odd powers when you look at all the exponents here. So when I plug in those negative 1s, the negatives are going to come back, so it changes the sign. But we have a minus out here too, so that's going to cancel those both out. So this is just going to be minus 2 over 39. And this is just going to be plus 2/9 here. Just because those double negations. And this is going to be plus 2/7. Whoops. Minus 2/5. And minus 2/3. And then plus 2/3. All right. So now our final answer then is going to be, so the final painstaking answer is 464 over 4096. So there's our answer for this one here. Terrible problem to work through. Too many polynomials to deal with. But you get the idea. For the most part, you can plug these in your calculator unless otherwise specified. So this is the answer. I wanted to work it out by hand so you can see every detail. So hopefully this isn't too painstaking. It kind of was for me doing this video. So there's the answer.